So this is the first video in a series of videos where we're going to solve some tough integrals, and despite how simple this integral looks, it can actually be quite challenging if you haven't done any of these types. So let's just jump right into it. I noticed that there are two distinct functions, e to the x and cosine x, and so instinctively I'm going to use integration by parts to solve this integral. It's just a matter of what part of the function I decide to integrate and differentiate at this point. So I'm going to choose to differentiate e up to the x and to integrate cosine x. When you differentiate e up to the x, you just get e up to the x, and when you integrate cosine x, what you're left with is sine x. Now, with the DI method that I'm using for integration by parts here, you have to remember to multiply these functions here, and then to integrate the product of these two functions here. If you have some more questions regarding integration by parts using the DI method, you can always check out another video that I have. What this looks like once we've done all of the algebra is that integral is equal to e up to the x times sine x, and then we carry over the minus sign, minus the product of e up to the x times sine x. And again, this is all equal to the integral of e up to the x cosine x dx. Now, in order to solve this problem, we just have to use integration by parts one more time, but it can get kind of confusing here, so I'm going to put this integral in brackets to remind us to distribute the negative sign appropriately. So when we use the DI method one more time, I'm going to choose to differentiate e up to the x for this integral and integrate sine x. So when you differentiate e up to the x, you get e up to the x, and when you take the integral of sine x, you're left with negative cosine x. So what follows, including what we have here, is, and I'll just go ahead and use this orange pen, we have e up to the x times sine x minus, and then it's going to be the product of these two right here, so negative cosine x times e up to the x, and then the integral of the product of these two, so it's going to be minus the integral of negative cosine x times e up to the x, or in other words, plus the integral of e up to the x cosine x. And again, this is all equal to our original integral of e up to the x cosine x dx. Now, we'll go ahead and distribute this negative sign to both of our terms. Sorry, this was supposed to go there. And here's what we're left with. We're left with our integral is equal to e up to the x times sine x plus e up to the x cosine x, and then minus the integral of e up to the x cosine x. Now, we know that we've solved this problem once we get to the point where we have the integral, our original integral, on this side, and then we have a negative of the same integral on the opposite side of the equation. And the reason why is because when we take this integral, we can simply add it to both sides of the equation. Oh, forgot to add the dx there. And these two will cancel, and what we're left with is 2 times our original integral of e up to the x cosine x dx, and this is equal to everything that wasn't added to this side of the equation, so e up to the x sine x plus e up to the x cosine x. And the last step to solve this integral is to simply multiply both sides of the equation by 1/2. So we have that our integral e up to the x cosine x dx is equal to 1/2 e up to the x sine x plus 1/2 e up to the x cosine x, and we can't forget our constant plus c.